Good morning, Year 10s. Welcome to our introduction to hyperboles, otherwise known as reciprocal functions. Those two words are used interchangeably. Now, the most basic hyperbolic function takes the form y equals 1 on x. Now, we can build on that to say 2 on x, 2 on x plus 3, for example, but let's start off just with looking at y equals 1 on x. Now, this is just meant to be an introduction to this type of function. You'll go far further into it in Year 11. Right now, it's just to get a taste of it. A bit like in Year 9, you got a taste of quadratics. This year, we're going further into them. This year, you're getting a taste of reciprocal functions, exponential functions and circles. Next year, you'll go further into them. Alright, so let's consider what would happen to y when x is equal to minus 100. Well, 1 divided by minus 100 is going to be negative, so it'll be negative 0.01, or negative 100th. 1 divided by 100, negative 100th. Divided by 10. Negative 0.1, and now we get onto the graph we have here. But I just left them out there to show you that this gets very close to 0. If I divide it by 1,000, it would be negative 1,000th. If I divide it by negative 10,000, it would be negative 10,000th. So it would go up and up towards 0 here without ever actually touching 0. Because if I divide by an actual negative number, I can't get 0. If I divide by negative 2, the answer is negative 0.5. 1 divided by negative 2 is negative a half. 1 divided by negative 1 is negative 1. 1 divided by negative 0.5 is negative 2, because 2.5 is going to 1. 4.5 is going to 1. 4.25 is going to 1. 10, etc. So, let's just plot what's happening on the negative side so far. When x is minus 2, y is minus a half. When x is 1, y is minus 2. When x is a half, apologies, skipped one. Minus 1, minus 1. Minus a half, minus 2. Minus a quarter, minus 4. Minus 0.1, minus 10. You can see that that graph is going to go very, very, very close to the y-axis, but never actually touch it. So on the negative side, the graph looks like this. It's really hard to do this with a mouse. Going off that way. That's meant to be a smooth curve from the y-axis all the way through to the x-axis, but not touching either the y-axis or the x-axis. Now when x is 0, you can try putting this in your calculator, but 1 divided by 0 will come up with maths error or undefined. Now, there's a good reason why it's undefined, which we don't really have time to get into. If you're interested in it, and it is an interesting answer, click on that link, and then at the bottom, do keep clicking on to limits, and you'll start getting into what 0 divided by 0 is a real number, which is quite cool. But, once again, not to be explored here. You'll just have to take me at my word that 0 divided by 0 or 1 divided by 0 is not really a thing. We can't put it on the graph, it doesn't exist. But we can go to a small positive number. Now a small positive number, 1 divided by 0.1 is 10. 4, 2, 1, 0.5, you can check these if you want, 0.01, 0.01. What happens here is when it's 0.1, we're off the axes up here. 0.25, we're at 4. 0.5, we're at 2. 1, we're at 1. 2, we're at a half. And 4, we would be at a quarter. Here we go with my hilarious drawing skills again. Oh, that was better. Maybe curving that way is easier with the mouse. That line is meant to be represent everything but touching the x and y axis. It goes infinitesimally close to each of those axes, but can never cross them. Now, there's a special word for this. When a line gets closer and closer and closer to another line, but never touches it, that's called an asymptote. Spelt like this. Alright. Now, this graph here has two asymptotes. There is a horizontal asymptote, and the horizontal asymptote is on the line y equals 0. Vertical x equals 0. Essentially, we're describing the lines that our curve is getting closest to. So our curve here on the vertical axis, on the horizontal plane, those lines curve ever and ever and ever closer to that yellow line. That yellow line is y equals 0. Similarly, on the vertical side, and the highlight doesn't work vertically, but those red lines curve ever closer to that blue line without ever touching them, because it can't happen when they touch, because 0 here over 0 is undefined, or 1 over 0 is undefined. Right, now this means that there's actually some values that x can't take. So we can't put x equals 0 into this graph. And this restricts the number of numbers that x can be. In the past, the only time we've restricted x is when we've said, well, time can't be negative or the length can't be negative, so therefore we ignore the negative sides. But this introduces a concept that x can be anything except several things, or except one thing in this case. The word for this restriction is called domain. Domain is the set of all possible x values. So in our example, it is the real values except 0. Slash means except 0. Actually, it's that slash. What that means is that x can be any number except 0. We can substitute any number into this line here except 0. Now the range is a set of all possible y values. So you can think about it that y can be any value. We can draw lines across here, I hope you can see my cursor, to any value except, of course, 0. So it's going to be real except for 0. Now, when does this change? Oh, if you like Lord of the Rings, the Balrog function. Quite cool. Alright, and yes, I do have that on a t-shirt. Let's look at the general form of a parabolic function. The general form is y equals a plus b over x takes c, where a gives us the equation of the horizontal asymptote of y equals a, c is the equation for the vertical asymptote, x equals c, and I should say, note, this is the 0 slash root of the denominator. Try putting a quadratic on the denominator and see what happens. It's quite cool. B affects how steep the curve will be and its orientation. And you generally find B by substituting a point. So if you're shown a hyperbolic graph, you can tell what A and C are by where it asymptotes, where it curves off to infinity. B, you have to take a point and substitute it in. Now note, for year 10, typically A and C are 0. So really, you're most of the time this year going to be seeing equations that look like this. And that's it. We don't concern ourselves too much with the others now because we're just getting a taste of these. And they won't form a big part of this topic. But let's have a quick look at the graph of a couple more. So if we grab this one and ask it to graph, you should really get the mathematics plug-in if you haven't got it already for this. We can see that it has a vertical asymptote here. And if we scroll in, we can tell that number is, well, 2. There's 2 there. So we can say its vertical asymptote is at the line x equals 2. The curve is going to hug towards that line, but never touch it. Now, the horizontal asymptote, well, you can see it curves out here. 4 is there, so it's curving towards 3, but never touching it. If we go the other way, it's curving up towards 3, but never touching it. So we can say our horizontal asymptote is the line y equals 3. Our vertical asymptote is the line x equals 2. And it shouldn't surprise us that that there gives us the horizontal, that there gives us the vertical. Now the domain is every possible x value. If we look at the graph again, we can see that we can take any x value, so I could say x is minus 4 and draw a line up, or draw a line down, and I'll eventually hit a y value. So for every x value going up or down, I'll hit a y value, except one. If I sub in 2, x equals 2, I'll go up and down and I won't find a graph. I won't be able to hit it with a line. So our domain is real because every number except 2, not w, 2. Similarly, range is real, but remember what the asymptote was? 3. Everywhere on the y-axis there was an equivalent line, x equals except for 3. Now this one here, we should be able to predict the horizontal asymptote is going to be -1. The vertical asymptote is going to be the opposite of that, so -3. Let's have a look. Highlight, graph. So yes, curving off down, if we follow that line all the way down, we are eventually going to go very close to -3. It will just curve closer and closer to it. Now one thing you might notice with this, compared to the previous ones, is previously the curve was on this side and that side of the x-axis. So we call that the first quadrant. I'm pointing at the screen, which doesn't help you. The first quadrant, second, third, fourth. Previously, these were predominantly in the first and third. But the effect of switching that to -2 on the top switches this around to exist in the second and fourth. We'll look at this further in class. Right now, it's important to just get the notes down and look at the general form, and to understand what asymptote is, what domain and range are. Alright. Could you write down the equation of that graph, please, in your OneNote? Thank you very much, and I'll see you tomorrow.